Hello, I am Dr. Subhasini, working as Associate Professor in the Department of Computer Science and Engineering, SRM Madurai College for Engineering and Technology. Today we are going to discuss on Introduction to Operating Systems. What do you mean by an operating system? A program that acts as an interface between the user and the computer hardware is called as an operating system. So the major goals of the operating system are to execute the user program and solving the program easier, to make the computer system convenient to use, that makes an user friendly, also uses the computer hardware in an efficient manner. These are all the goals of operating system. So in this figure we are seeing the components of this system. So in this system we are having computer hardware. Hardware is nothing but the physical components of the computer are called as hardware, operating system, and then system and application programs. So the application programs and system programs are written by the user. The user can write the application program which will be converted by the translator. The translators are called as compiler and assembler. The compiler will convert the source level language, that is high level language, into the machine level language, and the assembler will convert the language into the mnemonics language, the text editor which is used to enter the text and modify the text, etc. The database system which is used to store our data permanently. So these can be connected to our hardware via the operating system. So let's go to the definition of operating system. So operating system is a resource allocator. What do you mean by resource allocator? So in a system we are executing multiple programs. All the programs need some type of resources. For example, keyboard or some other resources. It may be a file or it may be some input output devices, etc. So the main goal of the main function of the operating system is to manage all the resources between the processes and decides between conflicting requests of a client and fair resource use. Also, it is a control program. It manages and controls all the parts of the computer. It controls the execution of programs to prevent errors and improper use of the computer. So finally, a operating system is a system program or it is an application program which is used to connect the user and the hardware. So the storage structure of the computer. So in general we are having the main memory, secondary storage, hard disk and solid state disk. So main memory, one large storage media that the CPU can access directly. It can be accessed, the direction is called as random access. Typically it may be volatile, that is it may be deleted at any time. Secondary storage, it is an extension of main memory that provides large non-volatile storage capacity. Hard disk, glass platters covered with magnetic recording material are called as hard disk. It consists of the memory capacity is high. It consists of the disk is divided into number of tracks. The tracks which are divided into number of sectors. Each and every sectors can be divided into number of blocks. In particular block we can have we can store many number of data. Solid state disk, faster than the hard disk, and it is called as non-volatile. So our operating system acts as an interface between the storage devices and the user. If the user want to store the data will be stored in these devices. So whenever it is executed, the OS is responsible to bring this data from this memory into the user input. So the storage hierarchy can be organized in three ways. One is speed. Based on the speed we can organize the storage. Based on the cost we can organize the storage. And then volatility, that is volatile, whether it is deleted permanently or not. Based on this the storage structure is hierarchical. Caching. So the cache memory will act as a copy of the main memory. Almost frequent data items will be stored in cache memory. Whenever an OS is executing the program, first it will check into the cache memory. If the data is found, then it will be retrieved directly and it will execute the program. If it is not found, it will go to the main memory, then it will get the data and it will execute the program. For that purpose we are going for the cache memory. So the device driver, for each and every device there will be a device controller to manage the input output and provides uniform interface between the controller and the kernel. So this is the storage device hierarchy. Based on the cost, it will be allocated. So the registers is high cost, and then based on the it will be very fast also. The access is very fast. After that, the cache memory. After that, the main memory. After that, that is accessing from data from cache memory is higher than the main memory. And then solid state disk, hard disk, and then optical disk, magnetic tape. So this is nothing but our storage device. So in order to execute the program, we need some data. So the program and data will be stored in the devices. The storage structure we have seen. Now what do you mean by process? In order to execute a program, we need a process. So a process is a program in execution. It is the unit of work within the system. Program is a passive entity, whereas process is an active entity. Process need resources to accomplish a task. Already I told you the resources may be of any type. It may be a CPU, it may be a memory, it may be input-output devices, or it may be an files. So each and every process will need resources to accomplish a task, and also they have to initialize the data before it start executing. So the process termination requires handling of resources back to the OS. After the completion of execution, we need to hand over the resources to the OS. So a process can be executed by two ways. One is a single threaded program or multi-threaded program. Single threaded means a program is divided into a single unit that will be executed by a single thread. It has one program counter specifying the location of next instruction to execute. It provides execute instructions sequentially one at a time until completion. Multi-threaded process is nothing but a particular program is divided into different number of subtasks. Each task can be executed by every thread, and every thread having separate program counter to execute this. So there are many number of processes and many number of threads available. So the coordination between the processes will be monitored and controlled by the OS, and also allocating and deallocating the resources from the process to the process is done by our operating system. So in general, the process management activities are creating and deleting both user and system processes, and then suspending and resuming the processes, provide mechanism to process synchronization, and it provide mechanism for process communication. That is, whenever we are executing multiple processes, they will be communicated via inter-process communication. The inter-process communication, we are using many number of system calls that also handled by our operating system. And what do you mean by synchronization? That is nothing but a mutual exclusion. Whenever two processes are going to access the same resource, that should have some mutual exclusion. When one process is enter into the shared data, at that time the another process will not access that data. That is called as synchronization. If both of them are able to access the same data, then we call it as deadlock. The deadlock also handled by the operating system. Then memory management. So to execute a program or all part of the instructions must be in memory. So all are part of the data that is needed by the program. And must be in memory. So memory management determines what is in memory and when optimizing CPU utilization and computer response to users. So the main job of the OS is to optimize the CPU utilization and memory utilization. In order to increase the performance level, the OS will manage this. So the memory management activities are keeping track of which parts of the memory are currently being used and by whom, deciding which process and data to move into and out of memory, and allocating and deallocating the memory space as needed. So these activities will be coordinated by the operating system. Next one is storage management. So already I told you, in order to execute everything, we need a storage. The storage can be in a file. So the file system management will be done by the operating system. File accessing, how we are giving the access control mechanism. If you are giving the access control to read only means, if you are the user wants to write the data by the at that time the OS will denying the access. The access control mechanism, everything will be handled by the OS. So the activities include creating and deleting the files and directories, and then primitives to maintain the files and directories. Then finally, operating system will maintain the protection and security. So protection means any mechanism for controlling access of processes or users to to resources defined by the OS. So using the OS, we can deny the access to the particular process. We can give whenever we are downloading some application in our mobile app, also we are giving the access to whenever we are using this particular application only, we are allowing the mobile phone or camera to access everything. Otherwise, we should not give that one. Then security. Defense of the system against internal and external attacks, that will also handled by our OS. So system generally first distinguished among users to determine who can do the what. So for that we need user identities, that is user ID. Security IDs include name and associated number, one per user. So privilege escalation allows user to change the effective ID and more. Right. So these are all the functions of our operating system. In general, operating system coordinates all the process execution, and then it will controls and manages the memory space, disk space, and storage space, and process management. So up to this we have seen the functions of operating system. Thank you.